All right, your warm-up. Write the equation in standard form. Pause the video, go ahead and answer the two questions, and then you can resume to check your solutions. All right, if we're writing our equation in standard form, you should remember that we want standard form to be ax plus by equals c, where a is always a positive integer. All right, so in order to get x up into the front, we're going to subtract 3x from both sides. That leaves us with negative 3x plus y equals negative 6. Now again, remember I said that it needed to be positive. Right now we have a negative 3 in front of x. So in order to make it positive, we'll practice what we did last week. We're going to clear the fraction essentially, or clear the decimal, but in this case we're clearing the negative. So we're going to multiply every term by negative 1. Negative times a negative creates a positive 3x. Negative 1 times 1y gives us a negative 1y. Negative times a negative again gives us a positive 6. And so now we have it in ax plus by equals c form. If it really bothers you that there's a negative in there, or the subtraction sign in there, remember you can always rewrite that as 3x plus negative y equals 6. I don't care, I will take either one of these two forms because they are both standard form. What is the opposite of 7? By now this should be a quick, easy answer, but let's review why. We have 0 on the number line. We move it forward 7 units, 2, 3, 4, 5, 6, 7. The opposite of 7 means that I'm going back to 0, and then I'm continuing 7 more units. 1, 2, 3, 4, 5, 6, 7. And so that would be 7 units into the negative direction. The opposite of 7 is negative 7. Solving systems by elimination. Here are your steps, and your steps are going to make a lot more sense once we get into working with them, because right now you see a lot of letters, and the letters can sometimes be confusing. But I'm still going to give you the steps so that you can see it in this notation, and then we'll talk about examples live when we have them. Write your equations in standard form. So ax plus by equals c. Ax plus dy equals e. Multiply one or of your equations by a factor that will make a or b an opposite from the second equation. So I've gone ahead and adjusted the ax plus by is equal to negative ax plus negative dy equals negative e. Add the two expressions together. So when we add them together, you'll notice that some things start canceling out. Step 4, notice that your x term is eliminated. Sometimes it will be the x, sometimes it will be the y. It depends on which one is easier to eliminate. Combine your like terms and solve for the remaining variables. So y would equal a particular value in this scenario. Plug the value of your variable into one of your equations and solve for the other missing variable. Step 6, state your solution as an ordered pair, or in words if you're dealing with a word problem. So xy if you're dealing with an ordered pair, or x is equal to this many dogs, y is equal to this many cats if you're dealing with a word problem. A lot of times when you're dealing with word problems and systems of equations with word problems, you go ahead and use variables that represent the terms in the word problem. So you're not going to have an x and a y anyways. So let's solve some elimination. Remember, we said that our first goal was to get one of our variables to have its opposite in the two different equations. In this particular set of equations, I can already see that I have a positive 3y and I have a negative 3y. I already have a variable that has an opposite coefficient. So in this case, I can just add my two equations together. 4x plus 2x is 6x. 3y plus negative 3y is 0y. 8 and 16 is 24. Now, please do not get confused and think that this is just y all by itself. 0 times y is 0. That's gone. So 6x is equal to 24. We can divide both sides by 6. X is equal to 4. Now at this point, since we did not manipulate either one of these equations, we can plug x into either equation. So I'm going to go ahead and deal with the one that has smaller numbers. 2x minus 3y equals 8. My x value is 4, so 2 times 4 minus 3y is equal to 8. 2 times 4 is 8 minus 3y is equal to 8. I will subtract 8 from both sides, and negative 3y is equal to 0. Now, another common mistake we end up seeing here is, no, that can't be true. Negative 3y is not equal to 0. No, it can be true. We can certainly divide both sides by negative 3, and we get y all by itself. And in this instance, y is equal to 0. Now, we want to check our solution for sure. So I have an x of 4, I have a y of, that was not what I meant to write. We have an x of 4, we have a y of 0. We want to check our solution in our other equation that we did not use to solve for one of our variables. So 4 times 4 plus 3 times 0 equals 16. Well, 4 times 4 is 16, plus 3 times 0 is 0 equals 16. So we end up with 16 equaling 16, and that is a true statement, which means our solution that we came up with is accurate. Now's a good time for you to pause the video. You'll notice this problem is very similar to the previous one. Solve it, then come back and check your work. Welcome back. As I mentioned, this problem is very similar to the first one. We have two terms, two coefficients that are opposite of each other. So we can add all of our values together. 2x and 2x is 4x. Negative 2 and 2 is 0. Negative 8 and 4 is negative 4. So now we're just solving for x. X is equal to negative 1. Plug it back into our equation. 2x plus 2y equals 4. 2 times negative 1 plus 2y is equal to 4. 2 times negative 1 is negative 2, plus 2y is equal to 4. So we will add 2 to both sides. And 2y is equal to 6. I'm going to divide by 2 on both sides, and y is now equal to 3, and we have a solution. Our solution, negative 1, 3. Now, certainly we want to be able to check our solution. We already know that our solution works in the second equation because we plugged in the x value and it gave us a particular solution. We really want to know, is it going to work in the other equation? So 2 times negative 1 minus 2 times 3 should equal negative 8. 2 times negative 1 is negative 2. 2 times 3 is 6 equals negative 8. Does negative 2 minus 6 equal negative 8? Yes, it does. So we've done really good on this problem too. All right, now I do. Solve by the elimination method. Well, we're in trouble here because I don't have any opposite coefficients. All my coefficients are positive. Well, it's certainly possible to make one of them negative. Let's assume that we want to make this one negative. And so just like we did with clearing fractions, we're going to multiply the entire equation by negative 1. So negative 1 times 3x gives me negative 3x. Negative 1 times 2y gives me negative 2y. Negative 1 times 8 gives me negative 8. Now notice how I went ahead and multiplied and wrote the equation right under my set of equations. This means that I can combine these two equations because my lower one written in blue ink is a modification of the previous first equation. So let's combine them. 5x and negative 3x, that gives me 2x. 2y and negative 2y, well, that gives me 0. 12 and negative 8 equals 4. So we can divide both sides by 2. X is equal to 2. Now, here is one rule that I generally make. Yes, 3x plus 2y equals 8 is smaller numbers, and it's going to be easier and quicker. No, I do not generally prefer you to plug your value back into an equation that you modified. So, five x plus 2y is equal to 12. We're going to plug it in one that we didn't utilize or modify. So 5 times 2 plus 2y is equal to 12. 5 times 2 is 10 plus 2y is equal to 12. Subtract 10 from both sides, and 2y is now equal to 2. Divide by 2, and y is equal to 1. So we have a solution of 2, 1. Now, our solution should work in our second equation because that's the one we utilize to identify our value of y. We want to check it in our original first equation. 3 times our value of x plus 2 times our value of y should equal 8. 3 times 2 is 6. 2 times 1 is 2. Does 6 and 2 equal 8? Yes, it does. Oops. So we are good to go. Again, pause the video. Give this problem a try. All right, welcome back. We should have noticed that both of these 3y's are the same coefficient. We just need one of them to be an opposite. So I'm going to do the same. I'm going to multiply my first expression by -1, which will give me a -8x. That will give me a -3y. That will give me a -2. And now we're just combining our lower two equations. 2 plus -8x is -6x. 3y plus -3y is 0. -4 plus -2 is -6. Divide by -6 on both sides, and we'd learn that x is equal to a +1. So again, 2 times 1 equals 3y. Sorry, let's try that again. 2 times 1 plus 3y is equal to -4. So 2 times 1 is 2 plus 3y is equal to -4. We will subtract 2 from both sides. 3y is equal to -6. We'll divide by 3 on both sides, and y is equal to -2. So we have a solution of 1, -2. We want to check that in the equation that we didn't use. So 8 times 1 plus 3 times -2 should equal 2. 8 times 1 is 8. 3 times -2 is -6. So 2 does equal 2. We have solved our solution correctly, and 1, -2 is a proper solution for this problem. All right, back to I do. Solve by elimination. All right, here I see I have a 2p and I have a 2p. Well, I would probably want to multiply by a -1. That's going to give me a -2p. Plus q equals -2, and I'm going to combine these two equations. P's will cancel out. Q plus q is 4q equals 20. Divide by 4, and q is equal to 5. All right, so we're going to plug in what we know. 2p plus 3 times q equals 22. 3 times 5 is 15. Equals 22. We'll subtract 15. So 2p is equal to 7. We'll divide by 2, and p is equal to 7 over 2. Now, since we don't know what q or p represent in this particular problem, our solution would end up telling us that the value of q is 5, and the value of P is 7/2. No need to change it to a mixed number unless you know what you're dealing with in terms of quantities or values. You try. Well, if you're stumped now, you're going to realize, hey, I have got coefficients that aren't even the same. Is it possible for me to get one of these coefficients the same? Well, yeah, it is. I could multiply this entire second equation by 2, and that would give me a 2y. But notice that it would give me a positive 2y, which means now my coefficients would be identical. They're not opposites of each other. So let's save ourselves a little bit of time and hassle and multiply by a negative 2. So let's see what happens here. Negative 2 times negative 4 gives me a positive 8x. Negative 2 times y gives me a negative 2y. Negative 2 times negative 16 gives me a 32. And now we're going to be combining our first and our last equation. 5x and 8x is 13x. My y's eliminate. 32 and 7 equals 39. All right, divide by 13. X is equal to 3. So we're going to use the equation that we didn't modify or change in any way. 5 times 3 plus 2y is equal to 7. 5 times 3 is 15. Plus 2y is equal to 7. Subtract 15 from both sides. So 2y is equal to negative 8. And divide by 2 on both sides. And y is equal to negative 4. So we have a solution of 3, negative 4. We want to check it in our other equation just to make sure we didn't make any mistakes. Negative 4 times 3 plus negative 4 equals negative 16. Negative 4 times 3 is negative 12 minus 4 equals negative 16. That is, in fact, negative 16 on both sides, so our solution checks out. All right, again, we're noticing that things are starting to get a little messier here. Not only do I have coefficients that are all different, but I can't just multiply one of these equations by a single value to get matching coefficients. So this is where we want to look for our small values and multiply one of them by the positive coefficient and multiply the other equation by a negative coefficient. So let's demonstrate. I'm going to multiply this top equation by the positive coefficient below. So positive 3. 3 times 2x gives me 6x. 3 times 6y is 18y. 3 times 4, 12. I'm going to multiply the other equation by the negative value of its coefficient from the first equation, negative 2. So negative 2 times 3x is negative 6x. Now we should see why I did that. Notice that I have a positive and its opposite coefficient here for the x's. So those are the terms that are going to eliminate. Yes, we still need to distribute the rest of these so we can find out the other values. Negative 2 times negative 7 is positive 14y equals negative 2 times 6 is negative 12. All right, so 6x and negative 6x, that eliminates. 18 and 14 gives me a 32y equals 12, and negative 12 is 0. Oops. So we divide both sides by 32, and y is still equal to 0. Well, now since we've utilized both of these equations, we're going to use either one of the originals. 2x plus 6 times the value of y, which we just said is 0, equals 4. So that will simplify out because anything times 0 is 0. 2x equals 4. Divide by 2 on both sides, and x is equal to 2. So our solution is 2, 0. Always good to check it in your second equation. We know it's going to work in the first one unless we made a mistake. We'll see if we made a mistake by checking it in the second solution. 3 times our x value of 2 minus 7 times our y value of 0 equals 6. 3 times 2 is 6 minus 7 times 0 is 0 equals 6. So 6 does equal 6. We're in good shape. Let's try another one together. So again, we can see I have coefficients that are not going to end up as easy quick opposites. So we're going to have to multiply both equations. I'm going to multiply this one by a 3. 3 times 2 is 6g. 3 times negative 3 is negative 9h equals 3 times 0 is still 0. I'm going to need to multiply this bottom equation by a negative 2. Notice I got the coefficient from its term here. By multiplying by the opposite coefficients, by multiplying each equation by the coefficient from the opposite equation, we're creating a common factor. So negative 2 times 3 is negative 6g. Negative 2 times negative 2 is positive 4h. Negative 2 times 5, negative 10. Combine our terms. Again, our g's will cancel out. Negative 9 and 4 gives me a negative 5. H equals 0 and negative 10 is negative 10. Let's divide both sides by negative 5. And h is equal to 2. All right. Again, we utilize both equations, but we're going to use one of our originals. 2g minus 3 times our value of h should equal 0. So 2g minus 6 is equal to 0. Add 6 to both sides. 2g is equal to 6. Divide by 2, and g is equal to 3. Now, just to make sure we didn't do anything wrong, let's check our solution. 3 times our value of g, which is 3, minus 2 times our value of h, which is 2, should equal 5. 3 times 3 is 9, minus 2 times 2 is 4. Does that equal 5? Yes, 5 does equal 5. We're good to go. We know that these are our values for our solution, but since they are not x's and y's, we're going to write out our solution. The value of h is 2. The value of g is 3. And when you have word problems that represent the g and h, you will state what those values represent. So the quantity of boys is 2, the quantity of girls is 3, something like that. Why don't you go ahead and pause the video and give this one a shot. All right, welcome back. So we have a 3 and 4. All right, we can multiply our top equation by 4. 4 times 3 gives me 12x. 4 times negative 6 gives me negative 24y. 4 times 30, getting a little bit bigger, but that's okay, we can handle it, equals 120. Now our bottom one, in order to end up with an opposite coefficient, we need to multiply by the negative value of the previous term. Negative 3 times 4 is negative 12x. Negative 3 times negative 8y is a positive 24y. Negative 3 times 50, negative 150. Now, hopefully by now you're starting to see something's happening. Let's keep working. Negative 12 and positive 12 gives me a 0. Negative 24 and positive 24 gives me a 0. Equals 120 and negative 150 gives me a negative 30. 0 equals negative 30. Now, unless you're in some really abstract math that I've never heard of, 0 does not equal negative 30. So at this point, we would say no, it doesn't. And your answer to the problem would be no solution. Now think for just a moment. If you're telling me that there's no solution, what does that tell you about these two equations? It tells me that these two equations are parallel. Now, we could isolate y and figure out if they really are parallel. 3x minus 6y equals 30. And so we're going to subtract 3x from both sides. So negative 6y is equal to negative 3x plus 30. And we're going to divide by negative 6 on both sides. And so we end up with y equaling, what is that, 1/2 x minus 5. That's one equation. 4x minus 8y is equal to 50. And so we're going to subtract 4x from both sides. And so we have negative 8y equals negative 4x plus 50. Divide by negative 8, divide by negative 8. And so we end up with a y equaling negative 4 over negative 8 is 1/2 x plus 50 over 8. Let's see, both are even, divisible by 2. 25 over 4, keeping a negative. All right, so a couple of things we notice. Both of these have the same slope. Both of these have a different y-intercept. So if we had two graphs where two lines had same slope and different y-intercepts, we'll notice that they would create a parallel line. Solve using the elimination method. Again, I'd like for you to pause the video. All right, welcome back. So we have 3j plus 5k equals 19. We have 4j minus 8k equals negative 4. So we're going to go ahead and create our opposites. Where's my pen? There you are. We will multiply by 4. 4 and 3 is 12j plus what is that? 76. All right, we're going to multiply our bottom one. Again, we want an opposite leading term here, so we'll multiply by a negative 3 to end up with a opposite negative 12j. Negative 3 times negative 8 is going to give me a positive 24k. Negative 3 times negative 4 is going to give me a positive 12. All right, let's clean this up a bit. So we have 12 and negative 12. Where's my pen? Cancels out. 20 and 24 gives me a 44k. 76 and 12 gives me an 88. And so we divide by 44 on both sides, and k is going to be equal to 2. We can plug our k into one of our equations. 3 times j plus 5 times our k value of 2 equals 19. 5 times 2 is 10. So we're going to subtract 10 from both sides. 3j is equal to 9. Where we'll divide by 3 on both sides, and j is equal to 3. Let's check our solution. 4 times 3 minus 8 times 2 should equal negative 4. 4 times 3 is 12. Minus 16 equals negative 4. 12 minus 16 is negative 4. That does equal negative 4, so we're in good shape. The value of j is 3 the value of k is 2.